right, good morning or good evening. Today we are going to be in topic 10, representing and interpreting data. We're going to be in block 7 today. And our goals and objectives in this block are going to be to find measures of center, make observations about the degree of visual overlap of two numerical distributions, make inferences, make inferences about two populations using measures of center and measures of variability. So to get started today, what I want to talk about is say that you were with your friends and the principal came to you and she said, I don't really know if we should build a track or the tennis court. And she wants your opinion about some other options for the school. If you had some input on what your school could build, what do you think it would be? What would you want, Layla?
Um, I guess like an art studio.
Okay. What do you think, Najela?
Maybe a basketball court.
Okay. What do you think, Christopher? If you had the chance to have anything built for you at the school for like you and your friends to use, what do you think, Deonti? Or Abigail?
Football field.
A football field? Good. What do you think, Haley?
The area of like if you get stressed out or anything, you can go and chill there.
Okay, that's cool. All right, so those are all great ideas. So, what do y'all think are some other ways to decide which one of those to build other than asking people how much they would use the track or tennis courts? Can you think of any other way that you could decide whether or not something should be built?
You could think about how much it would be used.
Okay, that's perfect. All right, so we're going to build off of that. So, since you said that answer, Haley, if you don't mind, would you go ahead and read this for us?
When the principal thinks the decision about the park has made, the environmental club members announce they have a better plan. They want a greenhouse and butterfly enclosure. Why do they consider this plan? They say that greenhouse and butterfly garden can used in any kind of weather, while the multi-purpose track and tennis court would go unused on rainy days or really hot days. To prove their case, they must collect data. They start by considering very hot days. They believe the outdoor
Facilities?
facilities will not be used on any day when the temperature is 95 or above. How can they find out how often the temperature reaches 95 degrees Fahrenheit, and what kind of graphs could they use to represent their findings?
All right, so how do you think we could figure out how often the temperature reaches 95 degrees or hotter? What do you think, Tashandra?
Probably by collecting data on hot days or something.
So when is it hot? Is it hot during like the winter or the spring?
Spring.
Say that again.
Spring.
All right, maybe the spring. Do you think it'll get over 95 degrees in the spring?
Probably
No.
not.
Probably not. When does it normally get over 95 degrees here?
The summer.
The summer. Yes.
Summer.
So more than likely, if they want to find out how often the temperature reaches 95 degrees or above, they're going to need to look at what time of the year?
The summer.
The summer. All right. So let's see what they decided to do. It says instead of taking a survey about the usage of the greenhouse and butterfly enclosure, the environmental club members decide to collect data on the high temperature each day for 50 consecutive days during the 3 hottest months of the school year. So when it says 50 consecutive days, that means one after another. So for 50 days, they recorded what the temperature was. And then they documented how many of those days were above 95 degrees. So when they find out all this data, what kind of graphs could you use to represent this? What are some of the graphs that we've been using?
We use the bar.
Histogram.
Yeah, we've used a histogram, we've used a bar graph. What else have we used?
Box graph.
Yep, we've done the box plot. What about a dot plot? Have we used that?
No.
You don't think we used a dot plot the last couple of days? Where they put the little dot and they just kind of use them like tally marks?
Yes.
Yeah, we did something like that. All right, so let's see what they decided that we could use. They say that the numerical data can be organized into stem and leaf plots, histograms, box plots, or dot plots. So the only one that we didn't say was which one?
Stem and leaf.
Yeah, the stem and leaf plots. And I think that's just because, well, we normally use those at either the very beginning of this year or haven't seen them for a while. So I think they're just not fresh on our mind. But we could use stem and leaf plots, histograms, box plots, or dot plots to show our data. So let's see what page 6 has to say. If you did not answer question number 1 in your workbook, the information that we just got is what you needed to be able to answer question 1 in your workbook. So if you have not got that workbook open and you did not answer question number 1, you definitely need to do that now. Now, page 6, we're going to go through and we're going to look at this animation and we're going to try to just kind of focus on the histogram that we're looking at. So before we get into it too far, Lainey, can you read this for us, please, ma'am?
The top and bottom.
All of it, please.
The environmental club believes that when temperature is above 95 Fahrenheit, no one will use the multi-purpose track or the tennis court. The club members recorded the high temperature on 50 consecutive days. They want to present their data in a histogram, which histogram best represents their opinion. The students recorded temperatures for 50 days, and all the values were in range of 55 to 105. Look at all the choices, which best represents the environmental club's position.
All right. So looking at this, what are the intervals of temperatures here?
$55 and $105.
Well, think about the intervals. Look over there on that left side on the blue. What are the intervals that they're going to use?
50, 25, 10, and 5.
Correct. Does that make sense to everybody? How many days are in the interval?
0 to 50.
Correct. And then we already heard this, but what is the length of this interval? We said how many degrees in Fahrenheit? It's from what to what?
55 to 105.
Correct. All right. So what we're going to do is we're going to take a look at this. We're going to start with 25 degrees, and we're going to see which one of these histograms that we think would be the best to represent the club's opinion and why? So looking at this, does this give us a lot of data, or is it kind of spread out or too close? What do y'all think? We're not real sure. Let's compare it to 10 degrees. Let's take a look at 5 degrees. And let's take a look at 50 degrees. Is this one going to be helpful?
No.
No, not at
No.
all. So we know the 50 degrees is out. Let's start back at 5 degrees. So out of 25, 10, and 5, which histogram do you think would best represent the club's opinion of that if it's 95 degrees or hotter, that we would not use the track or the tennis court? Which one would you rather use? The 25 degrees, the 10 degrees, or the 5 degrees?
10 degrees.
I agree with you, Eli. 10 degrees is going to best represent the club's opinion. Now tell me, why do you think this, though?
It's like more in between. It shows the number of days more accurately than the 5 degrees.
Okay.
And it's more spread out than the 25 degrees, so it shows the degrees better.
Okay. Do y'all agree with this statement?
I agree.
All right. So let's take a look at page 7, which is going to allow us to answer question number 2 in our workbook. So did the environmental club choose the same graph as we did? Did they pick the same one as Eli said?
Yes.
Yeah, they did. So it says the environmental club members want to show that for the most of the days they collected data, the temperature reached at least 95 degrees. So here's the histogram that they choose to present. So it says, what does the histogram tell us about the number of days that the temperature rose to 95 degrees or above? So we're discussing this right here. So how would we tell how many days that it reached 95 degrees or above? What would we need to do with the top of this? Could we see where it goes on our temperature? On our number of days? Couldn't we just draw a straight line like that?
Yes.
Yeah. So about how many days would that be?
18 or 19.
Yeah, about 18. All right, so let's take a look at it. It says for a total of 18 days, the high temperature was at least 95 degrees. The interval from 95 degrees to 105 degrees contains the most number of days. So did most of the days they measured reach 95 degrees? They did 50 days. Did most of the days reach 95 to 105 degrees? Yes or no?
Yeah.
All right. So they looked at a total of 50 days, right? And only 18 of them were 95 to 105. So I'm going to subtract, and what I'm going to do is I'm going to try to figure out how many days didn't reach 95 degrees. So what's 10 minus 8?
2.
And 4 minus 1.
3.
So 32 days were below 95 degrees. So did most of the days they measure reach 95? No, it did not. So they recorded the high temperature for a total of 50 days. If most of the days had reached 95 degrees Fahrenheit, then more than 50% of the days, or 25 days, would have reached the temperature. 18 days out of the 50 did. And so if we do 18 divided by 50 in our calculator, we get 0.36 or 36 hundredths. And we know that if we multiply that by 100, we know that 18 out of 50 is 36%. So do you think this is going to be helpful for them to present to the principal?
Yes.
All right. Why do you think that it would be helpful compared to the multipurpose track and the tennis court data?
I think it'll be easy for them to present it to the principal because it'll show how many days will be hot and how many won't.
Okay. Do y'all agree with what Najela's saying? Do y'all agree with what Najela's saying?
I agree.
All right. So I'm thinking that you are going to be able to present that, but I kind of feel like they're going to need a little bit more data. Like I feel like they need to know, about how many days it rained and about how many days are, too cold to go out there. Because they were talking about it being too cold, too hot, or it raining, you wouldn't be able to use it. I think with just seeing this and the principal looking at it and just being like, well, that's only 18 days that it's not going to be used. I feel like they need to gather some more information. What do y'all think?
Yeah, I agree.
Okay. So let's take a look at this. Zayden, can you read this for us?
Yes, sir. You want me to read the first one and the second one?
Yes, sir. I want you to read every bit of that, please, sir.
All right. The environmental club members do not give up. They decided to think about the data in a different way. Instead of providing that most of these days reach 95 degrees, could they prove that a typical high temperature for the 50 days was at least 95 degrees? If so, they will argue that on typical days during the hottest month, the multi-purpose track and tennis courts would go unused. Remember the mean, median, and mode. Each of these measurements can provide an example of a typical temperature. If the club has a list of 50 values in the data set, they can find the mean, median, and mode of the data.
All right. So how would the environmental club members find the mean temperature? What would they do? Out of the data that we just found, what do y'all think, class? How would you find the mean temperature out of what they just discovered out of those 50 days?
They can add all 50 and then divide.
Correct. By the number of divide by what?
The number of days?
Yeah. So the club members would add all 50 values and then divide by 50 to find the mean temperature. Great job, Najela. So the next question says, and remember, this is question number 3 in your workbook. If you're not doing that right now, you definitely want to be doing that. How would the environmental club members find the median temperature? What would we do to get the median?
They had to find the 25th and 26th value.
Correct. And then what are they going to have to do with the 25th and 26th value? Since those are both in the center, what do they have to do with those?
Divide by 2.
Yeah, you add them together and divide by 2, and that's going to give you the average. If the 25th and 26th value are the same, then you know it's just that number. But they're different values, like say, and of course they're not for this, but if they were 2 and 3, you'd add 2 and 3 and you'd get 5 and divide it by 2, and so your median would be 2.5. So great job. So their list has an even number of values, so the club members would have to find the mean of the 25th and 26th values. And when we say mean,
Mr. Moore.
that means that we're going to find the average of those. So that's what we would do to find the median. So how would the environmental club members find the mode temperature?
They would look for the temperature that occur often.
Yeah, the one that occurs the most is the mode. So that's what we would be looking for. So at this time, if you do not have question number 3 answered in your book, I'm going to give you just a couple seconds to go ahead and use this information to answer question 3 in your workbook. So I definitely want you to do that now. Okay, let's go ahead and move to our next page, page 9. And so this is going to let us answer question 4 in our workbook. Anytime that you don't really know what you should be answering, or you're kind of confused at where your questions are, if you look in this top right-hand corner, you can always see what question that it is going to help you with to solve. So looking at this, it says the environmental club members have lost the original set of values. Can they estimate the mean and median using the histogram that they created? So it says first estimate the mean, and then we're going to move the triangle to the point where you think the mean would be located. So we know that we have something from 55 to 65, about 3 times as much there. And then it just kind of keeps going up, doesn't it? So how could we estimate where the mean would be? Just using the histogram. Do y'all remember? What could we do? Now we said that the mean is the balance point. So what could I do to these shapes to make it all balance out so we could see what would happen, like say we were to splice this up and take these and bring them here, and maybe that on top of that, maybe, and get it all set up, where would it be most likely the balance point? Would it be way over here? Or here? Here? What looks like would level it out? What would be the balancing point?
Maybe 85.
All right, so let's take it to 85 and see. Ooh, we leaning. So at 85, we're still kind of leaning, aren't we? So what do I need to keep doing?
Move it to the right.
Yep. So 95 is too much. 85 is too little. So what do I need to do?
Go in the middle.
All right. So it says the mean is approximately 89. It's not exact, but this gives us a good idea. So now we're going to try to find the median. Remember, the median is the middle of the data. So where's the middle? Where do you think the middle would be? What do you think? Where's the middle? Is it at 55?
No.
No, look what it says. It says the area on the left of the median should be the same as that on the right. So what do I need to do?
Keep moving.
So where do you think I should go to? Somebody else can help too. Does this look good?
You probably can go to somewhere between 85 and 95.
Good job. So it says, great. We know that the median is somewhere between 85 and 95 degrees, and you cannot tell for sure the exact median, but 90 is a good approximation. You can tell it is the median because when the areas are leveled, the area to the left of the median matches the area to the right of the median. And so they did that by breaking it apart, kind of like what I was showing y'all earlier. So I'm going to show that one more time. Watch what happens whenever we pull it. Well, that was our mean. And then watch what happens when we take the median. They're going to cut the pieces up and they're going to level it out, okay? So watch how that works. Isn't that interesting? And that shows you the middle of the data. And so that is our answer for question number 4. So looking at page 10, you'll notice that we have multiple histograms here. And so we're going to discuss what the environmental club might be thinking. So why do you think they looked at a sample of 50 days? Why do you think they chose 50 days? What did the multi-purpose track people and the tennis court people use for their sample? They used what? Did they use 10 students? Did they use 20 students? What did they use? In our previous lesson, how many students did they use? Nobody knows. That's all right. It was 50 students. They used 50 students. So why do you think they chose to use 50 days?
Because it was the same amount that they used for the multi-purpose track.
Correct. All right. So they used, for the multi-purpose track, they used 50 students. For this, they used 50 consecutive days. So it kind of sets their data up similar, right? So, Isabella, it says the environmental club found the data. They wonder how different the data might look if they took a random sample of 50 days of the previous year and recorded the high temperature. So, Isabella, what do you think? What comparisons can you make about the two graphs? Help her out, Abigail. What comparisons can you make? Like, how are they similar and how are they different?
They're different because one says temperature for 50 consecutive days, and the other one just says a sample for 50 days instead of consecutive. I don't know.
Okay, that's possible. Okay. And consecutive means one after another, right? So they could have picked these temperatures any day throughout the year. Great job. Does anybody else see something?
The mean on the sample days is smaller than the consecutive days.
Okay. Yeah, so it's like the temperature's cooler out, right? What about the range? There's a big difference in the range too, isn't it? How many degrees difference is that?
33.
33 degrees. That's correct. So let's take a look and see what they say. Tashandra, tell us what they said.
The mean of the sample is lower than the mean of the 50 consecutive days. The mean absolute
Deviation.
deviation and range is larger in the sample than in the 50 consecutive days, which means that the temperature vary more in the random sample. The 50 consecutive days graph has more data points as you move up, while the sample graph has more of a peak in the center.
All right. So using this, today we should have learned how it's possible to estimate the mean and median from looking at a histogram. Were we able to do that today? Were we able to do that? To estimate the mean and median from looking at a histogram?
Yes.
Yeah, we were able to do that. And we did that by doing what? What did we have to do?
Put it in the middle,
Yeah.
like to balance.
Yeah, we had to balance it out and we kind of had to move it to the middle. So, what does it mean to balance a histogram? If we balance that histogram, we're moving our balance point to the what?
Center.
Yeah, to the center. That's correct. So, why does the median cut the histogram like roughly into two equal sections? Najayla just said it. It's because it's the what?
Center.
It's the center. Correct. So that's going to conclude our lesson today. And at this time, what I want you to do, if you're following along with me, the way that I would like you to follow along, the next thing that you would do is you would press this arrow. When you press this arrow, you're going to notice that you have questions 16, 17, 18, 19, and 20. So I want you to complete questions 16, 17, 18, 19, and 20 on your own. Make sure you're doing your very best. Remember, these questions are 2 points apiece, okay? So when you get them right, you're getting 2 points. You have up to 3 chances to get it right. So there's no reason you should miss one. If you do happen to miss one after you've tried it 3 times, I'm still going to give you 1 point for trying your best, okay? And if you choose not to do it at all, I can't help you any. You're just going to get a 0 on your assignment. So hopefully that's nobody here. Now, after we complete our more practice questions, pages 16 through 20, I want you to go to to your UpSmart Math. UpSmart Math is located at clever.com. You click on Edgenuity. When you click on Edgenuity, you're going to click on the UpSmart Math icon. Whenever you click on that, there are two things that are open for us. One is the measures of center of data, and the other one is statistical sampling. And so those are going to close this week. So I need you to work your hardest on getting those done and really putting the time in there so that we can see what's going on. So I hope everybody has a great day today, and I hope to see you tomorrow. I'll see y'all later.
Bye.